Welcome to Ask and Learn.
The domain for this function is x cannot be pi n. All right, intercepts. There is so let's write this. Every pi over 2 that we see, there's going to be 1 in each 2 pi period, you know? All right, symmetry, there's none. Asymptotes at x equals pi n. So the reason why the domain cannot have this is because there is an asymptote at this value, and the reason for that is because sine pi is 0 and ln 0 is undefined, so we cannot have that. So now let's do increasing decreasing intervals. So y prime is cosine of x over sine of x. Set that equal to 0, and we see x every pi over 2 plus pi n. So if we do the first derivative test for pi over 2, we're going to see it's positive here, so increasing here and decreasing there. So it's going to be a increasing to decreasing. So this is a local max at every pi over 2, because this is a periodic function, or has repeats. So that's for f prime. Let's write that in. This is f prime. Okay, and now we can look at f double prime to see concavity. So y double prime, the second derivative, is negative cosine squared x over sine squared x. All right, minus 1 equals 0. So we see an x at every pi over 2 plus 2 pi n, and x 3 pi over 2 plus 2 pi n. N is an integer. Okay, so this is for f double prime. F double prime, this is the concavity test. So this is pi over 2. This is 3 pi over 2. It's always going to be concave down, down, down. Always down. Okay. So let's graph now. So we have asymptotes at every pi. So if this is negative pi, this is pi. If this is 2 pi, this is negative 2 pi. Negative. Okay, and this is where our asymptotes are. As well as here. All right, so now we can see a local max at pi over 2. So pi over 2, 0 is that point. So pi over 2, this is negative pi over 2. I'm sorry, it's not here. Here. Okay, so it's going to be concave down. So see how it's increasing and then decreasing, and then also here it's going to be concave down, concave down. And notice the space, there's nothing here, nothing here.